How's it going, guys? Today in this video, I'm going to be going over a few problems on the test review. I'm not going over all of them, just kind of a little bit of each section, just to kind of remind you guys of how to do the problems, all right? So let's go ahead and get started. On this page, I'm only going to be doing the second one. I want you guys to work on the first one by yourselves. Remember, when it comes to these, we're trying to graph the function first before you find the domain. It just makes it easier anyway, even though we have to graph it anyway. So for these, remember, we always need to know what's happening at the endpoints. All right. So we're going to look at this domain, and we're going to figure out what our endpoints are going to be. Remember, infinity and negative infinity are never actual endpoints. They're just part of an interval, but they're not an endpoint. You can never equal a negative infinity or a positive infinity, so it just cannot be an endpoint. So the only endpoint we have to know is that 4. So we're going to take this 4, we're going to plug it into f of x, which in this case is 3 over 2x minus 2. That looks a little weird. There. We have a 4, we're going to plug it into f of x. And when you plug in 4 into that f of x, you should get 1. All right. So you plug in 4, you should get 1. So we have the range. We have the points 4, 1, and that's going to be a circle. All right. And then from here, we can plug in any other point that we want. That's between that domain. We need one other x value to figure out our domain. We need another x value in our domain to figure out our line. We need at least 2 points for our line. It doesn't matter what you choose, as long as it fits in the domain. 0 is probably going to be the easiest number in that domain to figure out, because we just get 0, negative 2. So our graph will look something like that. All right. The range, remember, the range goes from the smallest y value to the greatest y value. So we're looking at this graph. This graph is always going down forever. So that means our smallest y value is going to be negative infinity. And then if we look to the highest point, that 4, positive 1 right here, that's our highest point on the graph. So the y value of that is just 1. So that makes our range negative infinity to 1. And we use the parentheses for both of those because first you can never equal negative infinity, and also because that 4 is also a parentheses in the domain. So right over here, that's a parentheses. So we can never actually equal x equals 4. So when x equals 4, we can never actually equal that. So we have to put a circle there because that's what the domain tells us. So our range will also get a parentheses. All right, let's keep going. The next one I want to do is number 2. This one right here, number 2 and number 3 actually. So we're going to do this slide over here. We're going to write the domain and range of the function as an inequality. We're going to use set notation and interval notation to describe the end behavior of the function. All right, so the domain, remember, that's all the possible x values. So you look at this function on the right, we're going down and to the left forever and down and to the right forever. All right, on both ends, that's how we're going. All right. So that means our domain, if we're going to the left forever, our smallest x value is going to be negative infinity, and the biggest will be infinity. And that's how you write it in as an inequality. Set notation, remember, it's just an inequality with those fancy brackets. And interval notation, that's with the parentheses and brackets. We can never equal any type of infinity, so we just put parentheses for those. The range, that's all our possible y values. So if you look at the graph on both ends, we're going down forever. That means our smallest possible y value is negative infinity. And then if you look up the graph, the highest point that we have is at 3, positive 2, the vertex of 3, positive 2, and the y value of that is 2. And we can actually equal that 2, so y will be less than or equal to 2. Our set notation, that's just going to be the inequality with the fancy brackets. And interval notation is with the parentheses and the brackets. And we use a bracket for 2 because we can actually equal the vertex. The vertex is part of the graph, so y can equal 2, so we use a bracket. The end behavior, remember, that's going to be the behavior as the graph goes to both ends of the graph, or in other words, as x goes to negative infinity, and as x goes to positive infinity. As x goes to negative infinity, your f of x or your y's are going to negative infinity. As x decreases, as we start going left forever on the graph, we're going down forever, so we're going to negative infinity. And the same thing happens on the right side. If we go right forever, we're going to keep going down and down forever, so we're going to go to negative infinity as well. So as x goes to negative or positive infinity, it doesn't matter which one. Both ways are going to negative infinity. All right, and now for number 3, what is the range of the function in the previous problem if the domain is restricted to negative 1, 3? So we have the graph right here. I'm going to go ahead and restrict it from negative 1, so right here, to 3, right here. So when we restrict the graph, all we really care about is this sliver right here in the graph. Everything in between those lines, that's the only part of the graph I care about. So now I need to see what my range is going to be inside of that blue, inside those lines or on that blue line. All right. So my smallest y value, it's kind of hard to tell. It's this point right here, which is going to be about negative 2, 2. So I'm just going to say it's negative 2, 2, or negative 2, sorry. I'm just going to say it's that. And then my highest point is at the line right here at 3, 2. And if you look at the domain, they restricted us 2. We're including the negative 1 and the 3 in those in that restricted domain. So negative x equals negative 1 and x equals 3 are both part of that part of the function when we restrict the domain. So that means our range will be from negative 2 up to 2. Right, this is our smallest point right here, and it's part of the graph all the way up to this point right here. So our range is from negative 2 to positive 2. All right. So let's keep going. I'm doing number 5 here. I think that one's a little harder. I'll leave number 4 and number 6 for you guys to do on your own. But for number 5, we're told a tree that's currently 5 feet tall grows at an average rate of 8 inches each year for 15 years. We're going to write a function that models the situation to determine the domain and range in interval notation. So you want it in interval notation. So the very first thing that I see is that we're jumping from feet to inches, right? We don't want 2 different measurements. We want to keep everything consistent and the same. So I'm going to change 5 feet to inches. I just think having 60 inches rather than having 8 over 12 inches, whatever that reduces down to, 4/3 or whatever it is, whatever it is. I can't do math in my head right now. I don't want to have a fraction. Is my point when I'm converting 8 inches to feet. I don't want to deal with that. So I'm just going to change everything to inches. So 5 feet. That's 60 inches. All right. So now that I know that, now that I know that my tree starts at 60 inches tall, right? So if I start at 60 inches tall, and I'm going to add 8 inches every x years, every 1 year, but we're going to multiply that 8 times x for how many years it's been. Every year, we add 8 inches. Okay, so that means my height of the tree to my h of t. So as h of t, I should change that x to a t as well. So my h of t equals 60 plus 8t. My height of the tree, that's h of t, the height, equals 60 inches where we started, plus 8 inches every t years. So if it was 2 years, we add 16 inches to 60, we get 72. All right, so that's what my function is going to be. H of t equals 60 plus 8t. We start at 60, and every t years, we grow 8 inches. So we wrote our function, and now we're going to figure out our domain and range in interval notation. So the domain and the range. The domain, that's going to be time. Remember, domain will always be time. So in this case, we start at 0 time, at 0 years, and we go up to 15. So our domain in interval notation is 0 to 15. All right, and then my range, that one's going to be a little harder. We need to figure out what our beginning height is, which we know is 60. For the range, we know our beginning height is 60. And then we get taller we get 8 inches taller every year for 15 years. So what we're going to do is we're going to multiply 15 by 8, or really we're just going to plug in 15 into this equation. So an h of 15 equals 60 plus 8 times 15. 8 times 15, that's going to give us 120. So it's 60 plus 120, which equals 180. So the range, or the height of the tree, starts at 60 inches tall, and after 15 years, it's going to be 180 inches tall. All right, so we start at 60, and we go to 180. So number 4, number 6, I want you guys to do that on your own. The key to this is posted online already. So if you'd rather just go through the problems, you can do that. Or double check your work for some of the other problems, you can as well. On this page, I'm not going to do number 6. I'm going to leave that for you guys. I'm going to go on to the first graph on number 7. So for the first graph on number 7, on what intervals is the function increasing? So the function is increasing from an x value of -1 to the x value of 0. That's one interval. Then we're increasing from 1 to, it's hard to see, but we're going to that kind of vertex point right there at 1, or at 2, sorry. B, on what intervals is the function decreasing? So for decreasing, I'm going to do that in green. We start here at -3, and we decrease all the way down to that -1. And then we do, then again, at this x value of 0, we start there and we're going down or decreasing to a y value of 1, or an x value of 1, sorry. And then again, we start at this point right there, an x value of 2, and we're going to decrease down into that 3. Remember, intervals for functions are always going to be based on x. So you do not give it to me on y, do not give me points. Give them to me as x values, from an x value of -1 to an x value of 0, x value of 1 to an x value of 2, and so on and so forth. Even when we're decreasing or whatever, always give me the intervals in x's. All right. All right, and then for C, we're going to cross out this word local. We didn't teach you guys that yet. So what we're going to do is just look for the smallest point, or the biggest point, the maximum, or the smallest point, the minimum. So in this case, our maximum point here that we see, let's go ahead and erase all this. You see a little better. The highest point we see is at 1, right? A y value of 1 to be our maximum. And then for our minimum, the smallest value that we see is -3, right there. For D, list the domain and give it notation. And given notations, we want it in set notation. So we draw little brackets. The domain is x. So we put x such that our smallest x value is this -3 right there. It'll be less than or equal to x, which is less than or equal to this x value right there, 3. All right. And then for E, or our y values, again, and once in set notation, so do the fancy brackets, y such that our lowest y value of -3 is less than or equal to y, which is less than or equal to our biggest y value. That happens at 1. And we can see that the range of the range of the range, I guess, the interval of the range, is the same as your max and your min. And that's because the max and min are the smallest points, or the smallest y value, and the biggest y value. For the second part of 7, I'm going to let you guys do that on your own. Remember, the key is online, so you can do that on your own. For the same thing for 8 is very similar to the previous problem. That I'll let you guys do that on your own. On 9, the table shows some values of the polynomial function. So what we're going to do here, we're going to figure out our average rate of change, if it's positive or negative. We're going to give some examples of it. So a positive rate of change means that the graph is increasing, and a positive rate of change is how it's means the value of the graph is increasing. So some positive values of it, you can see if you go from 0 to 1, our y's go from 60 to 80. So that's going to be a positive average rate of change. We increase on average throughout that interval. We increase. All right, and then one more from 3 to 4. We start at 3, we go to 4, our y's go from 30 to 50. All right? And then for some negative ones, we're gonna do the same thing. We're gonna look for intervals where the y value decreased. Okay? So if we go from, let's say from 1 to 2, x is 1, then you go to x is 2, we go from 8 to 15. That's a decrease right there. We decreased on the range 1 to 2. So another one that we can do, and this one's gonna be a little trickier to see. Whoops. Is if we go from 0 to 2. We start at x equals 0 and we end at 2. Our y values are going from 60 to 15. So on average, the rate of change there is going to be negative because we decrease. All right. So the point of that is that the average rate of change doesn't just have to be from one point to the next. It doesn't have to go from 0 to 1 or 1 to 2, then 2 to 3. It can go from 0 to 2. You can have a bigger range than just going up 1 unit. All right. So from 0 to 2, we decrease going from 60 to 15. So that's why the average rate of change there is going to be negative, because we decreased. You have a negative slope. Number 10, I cannot get a calculator on the screen, so we're not going to do that. If you want to, you can go watch the previous video if you forgot. It's in your notes how to do it. So you could just follow the instructions either way. On the key, I think it has the instructions too. It'll give you the right answer, so you can double check the work there. But we're going to keep going. And on number 11, we're told to find the zeros of a function that's positive over intervals. All right, so those are our positive intervals right there. So I'm going to go ahead and draw a picture. Makes my life that much easier. So I have -7 way out here, up to 2. You're going to have 6, and I'll have 12 way out there somewhere. All right, so I'm told from -7, I'm starting at -7, and I'm going all the way to 2. All this right here is positive. But everything after 2, that's going to be negative. So we're from 2 to 6, everything's negative. And I know it's going to be 2 to 6 because I'm told 6 to 12 is all positive. So from 6 up to 12 is positive. And honestly, I don't know what's happening after 12, but I'm going to assume we're stopping right on the graph of 12 because we're not told anything further than that. So I'm assuming everything after 12 is going to be negative. So it's going to go down forever. All right? So, and it doesn't really matter because all we really need to do is find our zeros. All right, so the zeros are the x-intercepts. We can look at the graph right here, and we can see that -7, 2, 6, and 12 are going to be all our zeros of the function. All right? So, -7, 0, 2, 0, 6, 0, and 12, 0 are all our x-intercepts of number 11. Number 12, I'm only going to do one of them. I'm going to do 12a. Like I said, I'm going to say each time I'm skipping a problem, the answer key is online. So just go look at it if you have to. So first thing I'm going to do is list out my A, B, H, and K. I really suggest you guys always do that. It makes your life that much easier. So you don't have to look at the graph and figure out the transformation. You just look at the parameters. So A is 2, B is 5. Remember, that's 1 over 5. That's saying 1 over 5 equals 1 over B. Or if you solve for B, you get B equals 5. Or another way, you just flip it to get your B. So our B is 5. Our H is 4. And our K is 7. All right? So that A tells me we have a vertical stretch by 2. That's what my A tells me. My B tells me we have a horizontal stretch as well by 5. That's a very ugly H. Horizontal stretch. My H, that's telling me we're going to the right by 4. And my K is telling me we're going up by 7. All right, you really, really, really do need to know your transformations. You really should be able to do these problems without any problem. Or if you don't, keep working on them because, like I said, I think I said in the previous videos, and if you're my student, you know you heard me say it 1,000 times by now. We're going to be dealing with this pretty much all year. You need to know your transformations. You need to know A, B, H, and K, what they do. You need to have your transformation rule memorized in that general equation that g of x equals A times 1 over B, x minus H plus K. All of that stuff you need to have it memorized, and you have to know it inside and out because the sooner you get that down, the easier the rest of this class is going to be. All right. So let's keep going. 13. So same thing. This is something you should be able to do very, I don't say easily now. It's still something new. So it's going to take some practice to get better at, but you need to have this down pretty well for the rest of the year. All right. So f of x plus 2, that's our k value. That's telling us we're going up by 2. That x plus 2, that's telling me my h is negative 2. I'm going to go ahead and write my k is 2 in the first one. So h is negative 2. We go to the left by 2. Negative f, that's telling me my a is negative 1. And remember, a's give you your vertical stretch or compression, right? So everything's vertical. So your a is negative 1, that's giving you your vertical reflection, or reflection across x. Across x-axis. 2 f of x, that's a is 2, that's your vertical stretch. F of 1 over 2x, that's your b is 2. Remember, you flip the b value, so we get a horizontal stretch as well, or not as well. We get a horizontal stretch. Here we have k equals negative 2. That's down by 2. F of x minus 2, that's h of 2. Remember, it's x minus h. So x minus h means your h is going to be 2. So we go to the right by 2. F of negative x, that's b equals negative 1. Remember, b's give you everything horizontal stretches or horizontal compressions. So the b, when b is negative, that's giving you your horizontal reflection. So it's a reflection across y, or across the y-axis. All right. And then f of 2x, that gives me a b value of 1/2. That's going to be a horizontal compression. I'm going to do h comp for short. And then 1/2 f of x, that's my a value of 1/2. And that gives me a vertical compression. Again, I'm doing v comp for vertical compression just to keep it a little shorter. All right. So these are all my transformations. Make sure you know these. It's going to be a big part of the test. And it's just going to be a big part of the whole year, all right? Let's keep going. All right, and number 14, the graph of f of x is shown below. G of x equals 2, f of x plus 3 minus 4. Apply these transformations to be given reference points from the graph of f of x and use the transform points to graph g of x. All right, so first thing we should always do is list out our parameters. Our a is 2, our b, we don't have one, so it's just going to be 1. Our h is negative 3. Remember, it's x minus 3. So x minus negative 3 gives you that x plus 3. Or just think about it as changing the sign. And k is negative 4. So my transformation rule, remember that's bx plus h, comma ay plus k. Our b, we don't have one. We have a h. So it's x minus 3, comma ay plus k. So a is 2, so 2y minus 4. All right, that's a transformation rule, and we're going to take each one of these points and we're going to plug them into that transformation rule to get our new points. So the first one we have is negative 3, 0. Or actually, I'm just going to list out all the points. Negative 2, negative 2, negative 1, 1. Then I have 0, 1, or sorry, 1, 0, and then 3, 1. Right, so these are my 5 transformation points, or my 5 reference points, sorry. I'm going to plug them in to my transformation rule. So these are my 5 points. I plug them all in, x and y, into those points. So remember, these are x's, those are the y's. When you plug them in, so negative 3 minus 3 gives you a negative 6, comma negative 4. Negative 2 minus 3 is negative 5. And then negative 2 into that transformation rule gives you a negative 8. It's a little cramped. Hopefully you can see it. Negative 1 will give you a negative 4. A positive 1 gives you a negative 2. And then 1, 0. 1 minus 3 is negative 2. Plug in 0, you get negative 4. Then we plug in 3, 1. 3 minus 3 is 0. and you plug in 1, 2 minus 4 is negative 2. So all we're doing is plugging in these x's and y's into that transformation rule to give us our new transform points. All right. So these are my points. I have negative 6, negative 4, that'll be right there. Then negative 5, 8, negative 5, negative 8, sorry, right there. Negative 4, negative 2, then negative 2, negative 4, then 0, negative 2. So remember, we need to make sure that we graph it according to. So from the first one to the second one, it's a straight line. If we're looking at the graph over here, then another straight line right back up, and then we have a little parabola up to there. That's not good, it's not perfect, but go from one point to the next, it should be a parabola. All right. So this problem, list out your A, B, H, and K, make your transformation rule, list out your reference points, and then plug it into your transformation rule to get your transform points. All right. So basically, we're just trying to transform this graph. All right, here I'm only going to do one of these again. So we have these 4 graphs, and we're going to figure out what the function for each graph is. Sorry. So you can see all these are quadratics. So what that means is that it's in the parent function f of x equals x squared. All right. So that means we're going to use the function g of x equals a. It should be 1 over b x minus h plus k. But when we're given a graph like that, we don't like dealing with b's because the 1 over b is just weird, it's ugly, it's confusing. We're just not going to deal with that. We're only going to deal with our a. So g of x equals a, x minus h plus k. That's what we're going to do. All right, so our vertex right here, 1, 2. Our vertex is 1, 2. That gives us our hk point. Right. Remember, the vertex is always hk. It is negative 1, 0 right there. That's going to give us our xy points. So our xy is negative 1, 0. So we have an h, k, x, and y. We're going to plug all of these into our g of x to get our equation. So g of x, or really just your y, is 0 equals some a value that we don't know times our x value of negative 1 minus our h value of 1. All that squared. That's what I forgot here. Put those squared. Sorry about that. So negative 1 minus 1 squared plus our k value of 2. So we're just going to solve this out for a. So I'm going to subtract 2 over to the other side. Negative 2 equals a. Negative 1 minus 1 is negative 2, all squared. Negative 2 equals 4a. Negative 2 squared is a positive 4. Divide by 4, and we get that a equals negative 1/2. So all we have to do, plug this a back to the beginning. So g of x will equal our a value of negative 1/2 times x minus our h value, which was 1 all squared, plus our k value of 2. Do not plug in your x or your y because those change, but the h, k, and a do not change. So that's where you plug those in. All right, and again, I'm going to leave the next 2 problems at 15 for you to do on your own. The video is already about 30 minutes long, so I'm going to end it right here, guys. So really, the biggest things I would really do, guys, is focus on those transformations. Those are very, very important. So focus on those. Make sure you have those down very well for the test. And the key is on Canvas, so double check the key on there if you need extra help. And other than that, guys, I really hope this video helped. And good luck on the test.